Setting up simulation motion. This video is illustrated using CATIA and Solidworks. The experimental articulator used here is lower in height than the standard size articulator. The height is lowered for scanning with the dental model on the articulator. The height of the articulator is limited by the scanner device. This experimental articulator is an articulator of an entity that exists in the real world. This image shows an experimental articulator scanned and visualized by reconstructing the data in CAD. A dental model is being mounted on an experimental articulator. The upper and lower dental models have just been mounted on the experimental articulator. The data was acquired with a scanner and the solid model articulator was reconstructed from the mesh data in CAD. Let us look at the paths of motion of the left and right condylar paths of the original articulator. The arrows are the driving sources for the movement of the left and right condyle ball of the articulator. The motion path on the working side is a curve connecting 3 points, which is a small arc. Move the viewpoint to the non-working side. The motion path on the non-working side is also a curve connecting 3 points and is a larger arc than on the working side. Using SolidWorks, the articulator is moved in a lateral movement on the right side. Multiple check-bytes were quantified by the experimental articulator as the amount of movement of the left and right condyle balls and the tip of the incisal pin. These were combined in CAD to create a curve representation of the paths of movement of the condyle balls and the tip of the incisal pin. In this example, we used the two-location check-byte method for unilateral lateral movements. We combined the numerical values in CAD to create curves that represent the path of movement of the condylar ball of the articulator and the tip of the incisal pin. Two images are shown. It shows the complete overlap of the probe for measurement and the ultra-compact articulator for simulation. The top image shows the overlap, and the bottom image shows only the ultra-compact articulator. This small image was created using CATIA. Using the simulation capabilities of CAD, the path of motion for the articulator was converted into a path of motion for the probe of a goggle-type mandibular motion measuring device. The probe traces the line of the travel path. The line of the travel path is fixed in space. Each tracer consists of 4 parts per location. The T-shaped bar that integrates the 3 tracer locations consists of 4 parts. The T-shaped bar is associated with the mandible model. Therefore, when the T-shaped bar moves, the mandible model also moves synchronously. The center of the right condyle ball of the articulator is set to the CAD origin. Change SolidWorks from modeling to motion mode. The settings are shown here. The simulation calculation has already been completed. Try to make a lateral movement on the right side. This is the view from the right front. This is the view from the lingual side. Tracer movement. Let's look at the tracer from another angle. Tracers at the 3 locations are synchronized. Try changing the view again. Zoom in on the tracing of the line.